Alright, last set of material. This will be on test 3, and then again we'll have the optional final exam you can take if you want to try to improve your grade. We won't have too many sections on test 3 since we're kind of behind, but that's okay. It is what it is. We've covered enough. Okay, or we will have by the time we get finished. So in section 3.1, we're still dealing with functions. Okay, but here we're talking about some things that are specific to quadratic functions. Okay, and we've already seen quadratics before. We've done quadratic formula and things like that already. Remember, the thing that makes a function quadratic is that the biggest exponent on a variable is a 2. Okay, so that makes it quadratic. And then we've already seen them in this form, this ax squared plus bx plus c form. That is the form that we're most familiar with probably right now. But we want to start out talking about a different way we can write these functions, and that's what our textbook calls standard form. Some books call different forms standard form, but this is what our textbook calls standard form. So anytime you have a quadratic function written like we're used to seeing it, like the first one up here, you can use completing the square to rewrite it in this standard form. And we're not going to worry about going back and forth between the two forms this semester, but we can rewrite it in this standard form, and the standard form would look like this. It would look like a times, and then we would have x minus some number that we're going to call h in parentheses squared, and plus k. Okay, so if we write our function in this form, something that's really nice is something that we call the vertex becomes apparent. So let's really quickly, before we go into that, talk about what the vertex of a parabola is. So quadratic function, there's two ways it can look, right? We can have a parabola that opens up, or we can have a parabola that opens down. Okay, and if we have one that opens upward, and then the very lowest point on that graph is what we call the vertex. Okay. Or if we have a parabola that opens downward, the very highest point as far as the y-axis goes is what we call the vertex. And so it's either the very lowest or the very highest point on the graph, depending on if the parabola opens upward or downward. And the thing about putting our function in this standard form up here, or if we have one given to us that's in standard form, is we can read off the coordinates of the vertex. So here, if we have this standard form equation, then that means that the vertex of this parabola is going to be located at the point h, comma, k. So you have to be a little careful. We're subtracting the h in here, so it's the opposite of h. We'll get positive h, and then plus k. That's our y value. Okay, so that's a really nice thing about standard form, is that we can read off the location of our vertex. Okay. What if our parabola is, or what if our quadratic function is not in standard form? How do we figure out the vertex then? Well, let's go back to our ax squared plus bx plus c form. Okay, we have something called the vertex formula we can use in this case. Sorry, my handwriting's sloppy today. And it looks scary, but it's really easy. It just looks intimidating when you first see it. So the vertex formula says our vertex, if we have a quadratic equation in this form, kind of the expanded form, ax squared plus bx plus c, the x coordinate is located at negative b divided by 2a. Okay, so we take our coefficients here, we take negative b, divide that by 2 times a, okay, and we get the x coordinate of our vertex. Then to get the y coordinate of our vertex, we take the x part and we just plug it in. So we have f of negative b over 2a. And this makes it look complicated, but remember, this is just going to be some number, and this is just going to be some number. So what this is saying is when we figure out the x coordinate, we take our x coordinate and whatever that number is, we plug it in for x. So we're going to plug it in there and there, and then see what number we get out. Okay, and that will be our y coordinate. And so we can find the vertex that way. Okay. Okay, something else important. We said when we're thinking about these, our vertex is either the very smallest point on the graph or the very biggest point on the graph. So we need to talk about how we know if our parabola opens up or if it opens down. Okay, because here in this case, if it's the very smallest point, that's what we would call the minimum of our function. Let me write that, not minimum. Okay, sorry, I got laughing at myself there. Minimum value of our function. Or if our parabola opens downward, it's like the mountain peak, so this would be the maximum of our function. Okay, so all quadratic functions are either going to have a minimum or a maximum, but not both. Right? You can see this one doesn't have the one on the left doesn't have a maximum because it keeps going up for forever, right? So it's going to get bigger and bigger and bigger. And then the one that opens downward doesn't have a minimum because it goes down toward negative infinity, right? So it goes down forever. So you either have a minimum or a maximum, and to figure out which one you have to know whether our parabola opens upward or downward. So we can look at our leading coefficient to figure out if we're opening up or down. So here, if it's in standard form, here's our leading coefficient, that A. And then luckily for us, if we look at it in the expanded form, our leading coefficient we also call A. Okay, so we look at that coefficient with the x squared term. Okay, and we say if A is positive, then that means we have a minimum value. Or we could also say F opens upward. It opens upward if A is positive, so we have a minimum value. If our leading coefficient A is negative, then we have a maximum value. Or you could say F opens downward. Okay. And then just one other thing to point out here. If we have our quadratic function in standard form here, in standard form, then we know our vertex coordinates are h comma k. So that means that this is h on the x-axis, okay? And the coordinates of this point, the coordinates of our vertex, in that case are going to be h, f of h. Okay, so that's another way of writing that if you see it. Okay. Alright, so let's look at a couple of problems here, okay? 1 second. Alright, sorry about that. I forgot to paste the problems I wanted us to look at in here, and I was trying to not make the screen jump around too much. Okay, so let's look at this one. This is one I've taken out of the textbook, but you have some in WebDesign that are similar to this. So we have a quadratic function. Okay, it tells us to find a few things here. The first part A, is find the coordinates of the vertex, and then the x and the y-intercept. So that's really 3 things. Okay. So first we're going to start with finding the vertex. Okay. And on this one it's not in standard form, so we're going to use the negative b over 2a and then f of negative b over 2a formula. Okay. So here, negative b over 2a, our b is 6, right? So I'm looking in here, so there's our b, and our a here is this negative 1. Okay. So negative b would be negative 6 over 2 times a, which is -1. That's -6 over -2, or +3. Okay, so that's going to be our x coordinate. And then now we're going to plug that into the function. So we're going to find f of 3. Right. So we're looking back at our function up here, and we're plugging in 3 in for x. So we'll have -3 squared plus 6 times 3 minus 5. So let's see what that works out to. And that'll be -9 plus 18 minus 5. So that gives us 4, I believe, there. Yeah, that'd be 9 minus 5 is 4. Yes, okay, so this is the y coordinate of our vertex. So our vertex is at the point 3, 4. And I just realized on this particular problem, I made us work way too hard on that. Okay, that's how you do it if you don't have a graph, but I forgot it gave us a graph here, so we can just pick it off the graph. So there's 1, 2, 3 on the x-axis, and then we got to go up 1, 2, 3, 4. So our vertex is at 3, 4. So I made us work way harder than we had to on that one. Okay? But if you don't have a graph, that's what we do. Okay, we'll do another one of those in a minute. Okay, now what about our x-intercepts? Remember, that's where we cross the x-axis. So since we have the graph, we can look here and see we have one x-intercept that is at the point 1, 0. And the other one is at 2, 3, 4, 5. So the other one is at 5, 0. Okay? So those are our x-intercepts. Okay. And then this last one, the y-intercept, would be easy on the graph, but if you look, our graph's going off down here, right? So we can't see where it crosses the y-axis. Okay, so an easy way, if you can't see on the graph, to find your y-intercept is to find f of 0. So what we're going to do is we're going to plug in 0 for all of our x's. So here's our function again, right up here. So we're going to have -0 squared plus 6 times 0 minus 5. And the good news is that anywhere where we had an x and we put in a 0, those cancel out. So our y-intercept is at -5. So if you see that, then anytime you have the function listed out, you can just look at the part that doesn't have an x. That's going to be our y-intercept. So our y-intercept here as a point is going to be 0, -5. And so that's our y-intercept. Okay. B says find the maximum or minimum value of f. Well, we've already figured out that our vertex here is at the point 3, 4. So first of all, our parabola opens downward, so we're going to have a maximum, right? No minimum. Okay, so the vertex, we've already found it, so it gives you the answer to 2 questions. So the x-coordinate tells us where the maximum or minimum happens, and then the y-coordinate, okay, tells us the minimum or maximum. So here, what's the maximum value of f? It's going to be 4. Okay, so max equals 4. Okay, that's our maximum value. Okay, and then one more thing here. Sorry, it says find the domain and range of f. Okay, so for all of these, okay, hear me, because this is good news. Okay, for all of these quadratic functions, the domain is going to be negative infinity to positive infinity. Every time you have a quadratic function, that's the domain. The only thing we have to think about is the range. Okay, and so to think about the range, you think about if you have a maximum or a minimum. We said our maximum here goes up to a y value of 4. Okay? So 4 is as big as our y values are going to get, and then our y values go down forever. So how small can our y values get? How small can our range get? Since it's going down, it goes negative infinity. And then the biggest it can get is 4. And since we can't actually get to 4 at the vertex, we use a square bracket. Okay? There's our range. All right, let's look at another problem. All right, this one doesn't give us a graph, so we do have to work a little harder. Okay. 1 second here. Okay, so first of all, you got a couple of these in WebAssign, and part A says express in standard form. Okay, you do not have to do this. Okay, so just leave it blank, and I will go through and I will give everybody the points back. Okay, for this one. If you want to do it for bonus, that's okay. But you can look in the textbook and see how to complete the square to do it, but you do not have to do this. This is not required. Okay. Not required. Okay, so where we want to start on part B. Okay. Part B, we're going to start with the vertex. Okay. So again, we're going to use the negative b over 2a. And then whatever that number is, we're going to plug it into our function. And we'll get the coordinates of our vertex like we did on the last one. For the x-intercepts, we're going to take our function, set it equal to 0, and solve for x. Okay. And then for the y-intercept, we're going to find f of 0, and that will tell us where our y-intercept is. Okay. So for the vertex, our a here is 7, our b is 14. Okay, so for our vertex, negative b over 2a, we're going to get negative 14 over 2 times 7. So negative 14 over 14. So this time the x coordinate of our vertex is 1. Okay. So then now we're going to take and plug that 1 in, find f of 1 to get our y coordinate. So we're going to have 7 times 1 squared plus 14 times 1. Okay, so that's 7 plus 14, so we get 21. So our vertex is at the point 1, comma, 21. Okay, it's our vertex. It was plus, not minus, right? Yeah, plus, okay. So 1, comma, 21. Now to get our x-intercepts, okay, we take our function, 7x squared plus 14x, set it equal to 0, and solve. Okay. If you really want to on this one, you can do quadratic formula. Okay, but remember the other ways we have to solve quadratic equations. One of those is factoring, and here we can factor out a common factor of 7x, and that makes this one pretty easy. And then once we factor, we set each one equal to 0 and solve. 7x equals 0, x plus 2 equals 0, and we solve. So here we divide both sides by 7, we get x equals 0. Here we subtract 2 from both sides. And we got to put these in as points, so if our graph crosses the x-axis at 0, that means we've got the point 0, 0. Yeah, we got the point 0, 0 on our graph. Okay, and if it crosses negative 2, we have negative 2, 0. So our x-intercepts, got 0, and then, well, it says smaller x value there, so we'll have -2, and then 0. Okay. And then for the y-intercept, we'll want to find f of 0. We've really already found the y-intercept if you've caught it. But if we want to find f of 0, to kind of go through the method here, then that's going to be 7 times 0 squared plus 14 times 0. What's that going to give us? That gives us 0, so our y-intercept is at 0, 0. That's what threw me off a little bit earlier. I wasn't expecting this one to have an x-intercept and a y-intercept at the same place on this one, but it did. Okay, so that's your method there. And anytime, okay, just one more word here. Anytime you see minimum or maximum, it asks you for the minimum or the maximum, think vertex. Okay, think vertex. So that'll get you through the 2 word problems at the bottom. Okay, just find the vertex of the quadratic it gives you, and you can get your answer for the 2 word problems from your vertex. Okay, let me know if you have any questions.